Okay, within the measurement division video, I'm going to start off with a definition of measurement division, and that is just distributing some amount of stuff to an unknown number of groups so that each group gets a known amount of stuff, and then we can count up how many groups you gave to. So our first problem is 2/5 divided by 7/3. So really we have 2/5 of a candy bar, and we want to give 7/3 of a candy bar to every person we see. If we're going to draw it out first over 2/5 and our 7/3, so our first step is we need to do common denominators. So in this case, we can just times 2 by 3 and 5 by 3, and then 3 by 5 and 7 by 5, because that will give us 6/15 divided by 35/15. Common denominators, they each have the same denominator, and then we're able to take our 2/5 and just make it into 3. So if we count out these squares, 1, 2, 3, 4, 5, 6, same thing, 6/15. And then we're going to slice these into 5s because we multiplied it by 5 there. And if you count all these squares up, you will have 35/15. So really what we just did here is we had 2 times 3 over 5 times 3, which is 6/15 of a candy bar, divided by 7 times 5 over 3 times 5, which is the same thing as 35/15 of a candy bar. So if you think about it even deeper, we had 6/15 divided by 35/15. So that is our new problem with the same common denominators. So why can we invert and multiply within fraction division? So now we really have 6 divided by 35 because we have the same common denominators. So where did this 6 come from? Again, this is just our 2 times 3, and this is just our 7 times 5. So if you look back to the normal, or the equation we started off to begin with was 2/5 divided by 7/3. Really, if we invert and multiply, 2/5 times 3/7 would give us the same thing as 6/35, just like I showed before. This proves that you always be able to invert and multiply.